नमस्कार दोस्तों, जय हिंद। द बोरिंग डायरी के एक नए एपिसोड में आप सबका स्वागत है। और आज के अ, एक सेकंड, आई थिंक देर आर सम इश्यूज। दोस्तों, जय हिंद। द बोरिंग डायरी के एक नए एपिसोड में यस, सो वी आर गुड टू गो। तो आज हम डिस्कस करेंगे कावेरी इंजन के इशू पर। एंड उज्जवल जी, नमस्ते। एंड वी विल वेट 2 minutes बिफोर वी स्टार्ट सो दैट सम मोर पीपल कैन जॉइन इन if anyone is going to join anyways. So first thing first, to everyone joining now, thank you for coming. I hope you will like this video. If you are not subscribed, please subscribe kare. It takes a lot of effort to create these slides and to bring you this level of analysis. And other than that, if somebody is watching this live after this video is or this live is over, still please subscribe and share the video, like the video. That will be very helpful. सो एवरीबडी, आई होप यू ऑल आर डूइंग वेल। आप सभी बढ़िया होंगे। आज के वीडियो का हम बस तो और 20-25 सेकेंड्स में हम स्टार्ट करते हैं वीडियो हमारे प्रेजेंटेशन को। बीइंग सेड दैट वी विल फर्स्ट गो ऑन टू डिस्कस व्हाई वी आर डूइंग दिस सेशन। सो लेट मी शेयर माय स्क्रीन। Yes, I will start the presentation now. So yeah, तो पहले हम ये डिस्कस कर लेते हैं कि what are the knowledge you will be getting today from this session. First is that we will discuss why this session, the context of this session. Then we will get into the technical comparison of the Kaveri engine, और वहाँ पे हम कंपेयर करेंगे कावेरी इंजन को एग्जिस्टिंग इंजन्स के साथ जो 4.5 जनरेशन की एयरक्राफ्ट्स है. देन वी विल गेट इनटू द इन्वेस्टमेंट कंपैरिजन. नाउ there is no the thing is there are some caveats here, but still the investment gone into the R&D of these engines need to be studied. Then we will get into the year wise improvement in the Kaveri engine, and with that will create a question in your mind that what exactly do we want. Next is the technological bottlenecks that we will be discussing in great detail, and we will also discuss the testing facilities that have been created in India, and what are the gaps there. And next is the what are the possible way out of these bottlenecks, since we are desperately in need of an engine. And next point is that who is responsible for this lack of foresightedness. So the context of the discussion जो है ये शुरू हुआ है LCA तेजस मार्क 1A के इंजन के डिलीवरी के कारण, जो कि G404 इंजन है, जो कि US से आने हैं. अब प्रॉब्लम ये है कि दी कावेरी इंजन वाज फंडामेंटली conceived as an engine that will be used as a primary engine for the LCA program, but it did not come out to be as well as expected. The fundamental reason for this was I don't know if you people are aware or not, but when the LCA Mark 1A program was being researched upon, a lot of testing was being done in the United States. So I think it's the either it's University of Buffalo, या फिर there is a lab in Buffalo in USA where a lot of the research and development part of the LCA Tejas Mark 1 or the LCA Tejas program as a whole has happened. This was before the 1998 nuclear test. Once the 1998 or 1999 nuclear test happened, a lot of restrictions were put or sanctions were put in on India, and after that those sanctions, our scientists were asked to leave the United States immediately, and since then a lot of progress that were being made on the LCA program went into vain, and that included the engine part. So आफ्टर दैट उसके बाद क्या हुआ, हमने कावेरी इंजन पे जो रिसर्च थी वो खुद करना स्टार्ट किया, एंड इवेंचुअली वी डिड मेक सम इंजन्स बट इट हैड मैनी इश्यूज, एंड बिकॉज ऑफ दैट that delays had happened. But we will come to see that what our country has achieved in the Kaveri engine with the amount of funds that have been given. The ROI has been excellent. People won't believe it, but believe me, if you compare the ROI, that is return on investment, the amount of investment that India has done and the amount of investment the Western countries or even China has done for that matter, उस हिसाब से India has done a fabulous job getting directly onto a 4 or 4.5 generation engine. Now enough of talking, let's get into the meat of the discussion here. So we will be comparing the Kaveri's thrust with the global competitors here. So we have the GE404, that is currently the primary engine for the LCA Tejas, both Mark 1 and Mark 1A, the RD33, the WS13 and the M88 engine, and GE414 is the engine for AMCA, WS13 is for the Chinese one, and EJ200 is for the Eurofighter Typhoon. So if you want to know which engine is on which aircraft, I will clear that to you. So the EJ200 is in the Eurofighter Typhoon, GE414 I think the FA-18 Super Hornet, M88 is on the Rafale. That's why I have there is a reason I have marked it in green in the table, and RD33 is on the on the MiG-29, and the GE404, as I said, is on the LCAs. WS13 I think is on the J20, and the Kaveri as such is the subject of our discussion. So when we plot a scatter plot where on the x-axis we compare the dry thrust. So dry thrust is basically the amount of force that the engine is producing without the use of an afterburner. So if you compare it with compare the Kaveri with other engines, one second, I will get my pointer. Yeah. So the amount of thrust dry thrust the Kaveri is generating is in the same, almost in the same category of the RD33 and GE404 and the M88. So it is currently producing around 50 kilonewton, anything between 48.5 to 50 kilonewton. And when we see that the M88 of the Rafale is in its dry configuration is 50 kilonewton, so is the MiG-29's engine, that is the RD33, and almost same for the G404 existing engine of the Tejas and WS13. Now I will say that take the Chinese numbers with a pinch of salt, but anyways these are the Chinese numbers are from many Chinese sources, so they have a habit of lying too. So I will say that take it with a pinch of salt. But in any case, the Kaveri in its dry format is a very good engine in my opinion, and it is comparable to any contemporary fighter jets engine in the medium category. So if we extend the scope of the graph to the weight, so this is where the Kaveri's problem starts. It's a heavy engine.
So because of the heavy engine, it has a lot. It faces the major challenges as of now. So if you see this weight parameter, so each color represents a kind of amount, the total weight of the engine. So I think the dry weight, that is without the afterburners. So if you compare the color wise, so green or bluish is a lighter engine, and the if the system, if the bubble is in red color, then it's a relatively heavier engine. So if you see that the Kaveri isn't particularly very yes, user X701, it's 1100 kg. No, it's not 1100 kg. I will come to that. It's 1180. I will come to that, user. Yeah. By the way, user, thank you for joining in. So please subscribe. So yes, the Kaveri engine is a heavier one, and this is where the problem, one of the issues lies. So if we come to the weight comparison, if we take the 1100 kg as the baseline, so it is not as if the Kaveri engine is extremely heavy. There are many engines that are basically of the same similar category. The Chinese are 1135, the GE414 is 1110, and the Kaveri engine, it's 1180. So even if we take 1100 as the baseline, we are 80 kilos above from getting into the contemporary or the peer jet engines. So what is the issue? So being a heavier engine, it costs the Kaveri a lot on the thrust to weight ratio. So its thrust to weight ratio is quite compromised because of the high, relatively higher weight. Again, I won't say this is a very the margin is too high, but there has been a lot of weight reduction exercises already on the Kaveri engine. अब उसकी वजह से क्या होता है कि जैसे जैसे आप जितना वेट रिड्यूसिंग एक्सरसाइजेस करने जाते हो, तो द अमाउंट ऑफ टेक्नोलॉजिकल प्रोवेस दैट यू नीड, इट बिकम्स वेरी चैलेंजिंग. सो दैट मीन्स अगर अब आने वाले टाइम पे हमें इसको लेट्स से इवन 100 किलो भी वेट रिड्यूस करना है, दैट विल टेक ऑलमोस्ट द सेम अमाउंट ऑफ एफर्ट दैट हैज़ गॉन into creating the entire engine altogether. That may be ये थोड़ा ज़्यादा लग सकता है सुनने में, but that is the issue with material science as such and electronics as well, कि आप जितना छोटा और हल्का करने जाते हो किसी भी सिस्टम को, it becomes more and more challenging to reduce the weight and size. So as you can see, the thrust to weight ratio here for the Kaveri engine suffers. Now specific fuel comparison. So I will say that specific fuel comparison wise, the Kaveri is equivalent to the M88 engine. So if you see all through these graphs and charts, you will realize one thing, that the biggest advantage of the Rafale engine is or the European engines in general, is that they are very light. So one thing that they have sorted out very well is their metallurgy. They have figured out their material science part very well, and that has helped them to achieve this kind of very low weight, and that helps them to actually improve their thrust to weight ratio of the engine. But you can see here the dry thrust and all that thing wise, the Kaveri is very much close to the close to M88, but in the total thrust case, that is when the Kaveri gets to its afterburner part successfully, it will create more thrust than the M88. So that is one thing. I will again that will raise a question that I will share with you guys in the coming decks, that why, if we say that the Kaveri engines, if Kaveri engine becomes successful, it becomes almost equivalent or in some cases better than the Rafale engine. So what makes us think that the French will do a transfer of technology to the to HAL or to DRDO और टू अस, और वो अब मार्केट में अपना ही एक कॉम्पिटिटर खुद बना देंगे. सो दैट्स अ क्वेश्चन दैट नीड्स टू बी गिवन अ थॉट by the people who are in charge of this thing कि एक्चुअली ट्रांसफ़र ऑफ टेक्नोलॉजी का जो बात हम करते हैं तो क्या उससे क्यों कोई कंपनी अपना कॉम्पिटिटर बनाएगी, डिस्पाइट द फैक्ट कि आपको मतलब हम साफ़रान को बहुत पैसा दे रहे हैं, बट वो क्यों अपना पॉसिबल कॉम्पिटिटर बना के अपना ही मार्केट में खुद की फजीयत कराएगी. इफ़ आई हैव टू बी अ बिट लाइट विद द लैंग्वेज. Now we will jump into the technical part. So you have to bear with me. We will discuss what have been the challenges with the Kaveri engine as such, and we will get into the hardcore mechanical engineering and material science part of this engine, and we will discuss in very in-depth analysis. So if you see that this is basically the cutout of the Kaveri engine, and these are, if you understand the parts, this is the fan, the high pressure compressor, combustion chamber, the low pressure turbine, and then comes the afterburner. So I went through a slide deck shared in some conference by some GTRE official. So there they shared the part wise issues that they have been facing. So the flutter for the fan and the high pressure compressor, that is the majorly the cold section of the engine, they are facing flutter and high cycle fatigue. And when it comes to the hot section, these issues are mostly related to or somewhere directly or indirectly related to the high temperatures and pressures that comes up in the combustion chamber and the low pressure turbine, and subsequently in the afterburner part as well. Ujjwal ji, does the current Kaveri uses? I think so. I think the newer one uses. I will come into it, Ujjwal ji. There is a section in this, and we will get into the hardcore details of single crystal blade. Don't worry, I have covered it here. So this is the, if you see, this is the list of issues that are currently existing in the Kaveri, or I would say this deck is from 2022. So in the 2022 part, in 2022 version of the Kaveri, these were the major issues. So if you ask me, according to me, my analysis is that when the engine is moving ahead into flight test bed in Russia, I think they have figured out a lot of issues, especially in the cold section. They may have figured out the flutter and high cycle fatigue in the cold section, which I will explain what are these issues and how do they look. Anyways, let's move ahead. So understanding high cycle fatigue. So if you see this diagram, this is basically stress strain curve for a ductile material, or let's say a metal. So if I have to explain you this, please stick with me. This is going to take some amount of efforts to understand, but कोई आपको इतने डिटेल में नहीं समझाएगा पूरे YouTube में कि एक्चुअल में हुआ क्या है. सो किसी भी मेटल को तोड़ने के लिए ना, या तो आप एक बार में एक पूरा अच्छा खासा फोर्स लगाओ, जिसे कि हम टेंसाइल स्ट्रेंथ बोलते हैं, तो वो एक बार में टूट जाएगा. बट अगर आप ऐसा करते हो कि आप टेंसाइल स्ट्रेंथ से कम फोर्स लगाते हो, बट आप साइक्लिकल वे में उसको साइकिल करते रहते हो जैसे, तो वो उसको उतना फोर्स लगाने की ज़रूरत नहीं है, वो कम फोर्स में टूट जाएगा. फॉर एग्ज़ाम्पल आप यू टेक लेट्स से साइकिल स्पोक. अब आप एक काम करिए, साइकिल स्पोक को एक बार में पूरा तोड़ दीजिए. तो उसमें मान लीजिए एक्स अमाउंट ऑफ फोर्स लगा, बट आप उस एक और साइकिल स्पोक लो, आप उसको लेके हल्का हल्का ऐसे बार बार तो मोड़ते रहो, आप देखोगे आफ्टर एन नंबर ऑफ टाइम्स आपने पहले जितना फोर्स लगाया था उसके कम फोर्स में ही वो जो साइकिल स्पोक है वो टूट गया. So when you see that when you see this turbine blade, here I have the turbine blade CAE analysis. So when you see deformation, so what are the forces on the primary forces, if you see primary forces on a turbine blade, so it is rotating at a very high speed, एंड उसकी वजह से उस पर एक अपना सेंट्रीफ्यूगल फोर्स होता है, उसकी वजह से उसके बाद ये एक यहाँ पे इसके रूट पे इसे फिक्स किया गया है, वहाँ पे एक फोर्सेस होते हैं और एयर फ्लो की वजह से, एयर प्रेशर की वजह से कुछ फोर्सेस होते हैं. सो यू विल सी दैट देयर इज़ अ लॉट ऑफ स्कोप फॉर डिफॉर्मेशन here on the upper part of the blade. So that is the problem that was causing that is causing failure in the engine blades in the earlier Kaveri engine, that there were deformations happening due to high cycle fatigue, and उसके बाद चीज़ों में इंजन में इश्यूज आने लगते हैं. नेक्स्ट इज द फ्लटर इशू, दैट इज व्हेन द एरोडायनामिक फोर्स that is the force of the air flowing and the elasticity of the metal. अब मेटल है तो मेटल का एक अपना elasticity रहता है, और उसकी वजह से जो फ्लो में जो इश्यूज रहते हैं यानी कि वेरिएशंस रहते हैं, उसकी वजह से आई डोंट वांट टू गो इनटू एक्सट्रीम डिटेल कि आप बोर हो जाओ, बट आई एम गिविंग यू एन आइडिया. तो उसकी वजह से ये जो तीन फोर्सेस एक्ट करते हैं तो उसकी वजह से बहुत ही एग्रेसिव वाइब्रेशन होने लगता है उस टरबाइन ब्लेड्स में. तो ये एक इशू है. स्क्रीच जो आपने आफ्टर बर्नर में देखा है कि बहुत श्रिल एक साउंड होता है, एंड लाइट अप, प्रेशर लॉस, बकलिंग, ये सब जो आफ्टर बर्नर में था, दीज आर प्राइमरीली बिकॉज ऑफ द हाई हीट. सो दैट्स अ kind of material science issue. Now coming to the single crystal blades. So coming to the single crystal blades, so we need to understand what is a single crystal blade. So if you see here, this is a microstructure of titanium or any metal you take. If any metal you take there and look it in the microscope, then you will see that there are these little terrains or grains like structure with the black color boundary to it. These are called the crystals. So these crystals are basically contain atoms of the particular metal. And what these actually mean is that the atoms in this case are aligned in different ways. I am oversimplifying, but this is the fundamental part, is that the atoms here in the polycrystal material they are aligned in different directions, and when these grains actually interact with each other, the boundaries are formed. So सिंगल क्रिस्टल ब्लेड में क्या होता है, ये बाउंड्रीज होती ही नहीं है. नाउ व्हाई आर दिस बाउंड्रीज बैड? सो योर whenever you see that a failure happens, a crack happens in a metal piece or something, these cracks actually initiate from these grain boundaries. So these grain boundaries, if these grain boundaries are removed, this will improve the strength of the object by many times, both the strength in general and the heat resisting capacity of the turbine blade. So this brings us to the diagram here. So this is a polycrystal, that is multicrystal turbine blade which is not a single crystal. This is columnar crystal, that is these are blades where the crystal have they are in the vertical direction, boundary grains, and the single crystal blade have no boundaries, no grain boundaries. So this is how a single crystal blade looks. The right one here is the single crystal blade. This is the columnar crystal blade, and this is the polycrystal turbine blade. So we are looking to get a success in this single crystal blade for fighter jets in this case. So how is this single crystal turbine blades created? So this single crystal turbine blade is a magic of cooling. We have to cool the molten metal in a certain way to get this particular structure, polycrystalline structure. So before that I will मुझे आपको ये समझाना पड़ेगा कि जब मेटल कूल होता है तो वो कैसे होता है, तो उसमें बाउंड्रीज ग्रेन बाउंड्रीज कैसे होती है. So let's move on to the metal solidification process. So let's say ये जो आपका आउटर सरफेस है, सोमनाथ जी आप क्या इंग्लिश में थोड़ा हिंदी में लिख सकते हो कि बाकी लोगों को भी थोड़ा समझ में आ जाए? थैंक यू. मोल्ड वॉल, या सो अगर आप जब देखोगे इसमें लिक्विड, अगर कहाँ था मैं, हाँ, लेट्स से आपने यहाँ पे मोल्टन मेटल एक ग्लास में डाला और बाहर से आपने ठंडा मतलब एनवायरनमेंट प्रोवाइड किया, देन these dendrites are formed, and these dendrites slowly move ahead towards the center of the whatever jar you have taken or the crucible you have taken for solidification, and these grains are formed. So this is the dendrite formation of in case of solidification of metal. So in case of these single crystal blade, ये जो कूलिंग होती है ना, जो वो कूलिंग ऐसे होती है कि आपको एक ही साइड से कूलिंग देनी है. जैसे कि अब मैं आपको कैसे समझाऊं, आपने देखा होगा कि तलवार जब बनाते हैं तो वो उसको एंड में गर्म लोहे को पूरा का पूरा पानी में डुबो देते हैं. सो जब आप पानी में डुबो देते हो उसको, देन यू आर गिविंग कोल्ड टेम्परेचर फ्रॉम ऑल साइड्स. बट व्हाट आई एम टेलिंग इज़ दैट अगर आप उस गर्म तलवार को बस उसके लोअर या फिर अपर पार्ट, यानी कि जो नुकीला पार्ट है वहाँ से ही सिर्फ उसको कूलिंग टेम्परेचर प्रोवाइड करते हो, तो उस केस में जो सॉलिडिफिकेशन होगा, या आई विल कम टू दिस द कंपनीज पार्ट, नो इश्यूज करी जी. So yeah, coming to the issue that coming to the part कि कैसे बनता है सिंगल क्रिस्टल ब्लेड. सो दिस इज़ अ ब्रिजमैन फर्नेस. यहाँ पे क्या होता है, आप देख रहे होंगे यहाँ पे, let's ओके, या सो ब्रिजमैन फर्नेस में क्या होता है, यहाँ पे आपको एक ये आपका फर्नेस है, यहाँ पे आपने मोल्ड्स रखे हुए हैं अपने टर्बाइन ब्लेड्स के, और नीचे से आपको कूलिंग या फिर जो आपको कोल्ड टेम्परेचर है वो सप्लाई किया जा रहा है थ्रू कोल्ड वाटर और वट एवर यू हैव. सो आप पूरे के पूरे ब्लेड को नहीं डुबो रहे हो फॉर कूलिंग, बट आप नीचे से उसको नीचे से कूलिंग टेम्परेचर दे रहे हो. एंड टू अवॉइड मल्टीग्रेन स्ट्रक्चर एक फ़िल्टर टाइप दिया जाता है उसको. वो एक हेलिकल 3D पाइप की तरह होता है, जिसे ग्रेन सेलेक्टर बोलते हैं या फिर पिग टेल भी बोलते हैं. तो उससे क्या होता है, ये जो मल्टीपल ग्रेन फॉर्मेशन यहाँ पे स्टार्टर में दिख रहा है ना, सो दिस फिल्टर आउट दिस मल्टीपल ग्रेन फॉर्मेशन, एंड इट अलाउज ओनली सिंगल क्रिस्टल to propagate upwards towards the hot chamber. So ऐसे बनता है आपका सिंगल क्रिस्टल टर्बाइन ब्लेड. इस प्रोसेस को या फिर कूलिंग प्रोसेस को बोलते हैं यूनी डायरेक्शनल कूलिंग. सो यहाँ पे है, यहाँ पे आप देख सकते हैं कि यहाँ पे जो आपका स्टार्टर वाला पार्ट है उसका एक डिटेल्ड व्यू है. यहाँ पे मल्टीपल ग्रेन्स हैं, फिर यहाँ पे एक सिलेक्टर या फिर पिग टेल लगाया जाता है. पिग टेल के थ्रू सिर्फ आपका एक ही क्रिस्टल ऊपर की तरफ सॉलिडिफाई होता जाता है, एंड देन इट बिकम्स देन द एंटायर मोल्ड इज सॉलिडिफाइड इनटू अ सिंगल क्रिस्टल ब्लेड. Now this is a deck that I don't know where did I actually get it. I think Strategic Frontier maybe. So this is from a 2022 deck that GTRE guys did. So they have pointed out what are the materials that they have to indigenize. So if you see that the red mark, they have marked this in red dots, the materials that have to be indigenized, you will figure out that most of these things are related to titanium. So the good thing about the titanium, we have a good news which I will be discussing in the next slides. So titanium thing has been a challenge for us because in general titanium across globe has been supplied primarily supplied by Russia and some handful of certain countries. I think even China is also in the is a major player in the supply chain. So that is one thing. So the good news is that PTC Industries has opened a furnace. So how many furnaces I don't know, but the investment says that it is there are more than one furnaces that has been opened for making these titanium ingots. So these titanium ingots are a very key issue in the engine and in the fighter jet development as well. So you need titanium alloys in the engine and you need the titanium alloys in the aircraft body as well. दोनों केस में आपको टाइटेनियम की बहुत ज़रूरत होती है because it's strong, it is light, and it is now has become the standard go to base material for high tech military grade equipments. Now comes the funding part. So these are some funding that I have understood that the Americans have actually pushed in more than $1 billion on their single engine. Single engine means on each of the engine development program. So they don't have just one engine program that's running, and वो लोग पानी बहाते हैं engine development पे. Or I will come to the joke that has been created out of Kaveri. But if you see that this is a $1 billion mark, a $1 billion mark. So for an engine development program, so they have developed for jet engines. Americans have developed jet engines for. Okay. So Somnath da, I understood. Japan is also yeah. Thank you. I will come to the questions. Once I am done with the presentation. Yes. So coming to the Kaveri thing. So the joke of the Kaveri engine is that we have been able to create a engine that's providing us with almost 71 kilonewton of thrust, albeit with some struggles. That is very much close to maybe not close to what was needed for the LCA Tejas, but it's close to many fourth generation fighter jet engines. We have compared with some of them, so in the 70 to 75 category, the one of them being the RD-33. So the RD-33 on the MiG-29 is one such engine that I think the Kaveri spec wise comes close to, but 38 years and only 2100 crore, and here people say कि भाई DRDO ने पैसा डुबो दिया है. Like are you guys serious? और ये लोग जो बोलते हैं कि भाई DRDO ने कावेरी पे पैसा डुबो दिया है, और ये जो सो कॉल्ड एनालिस्ट होते हैं, ये हर बात पे तो आप LCA तेजस को फॉरेन प्लेटफॉर्म्स के साथ कंपेयर करने निकल पड़ते हैं, बट दे डोंट कंपेयर द फंडिंग दैट दीज प्लेटफॉर्म और देयर इंजन्स हैव गॉट. What we have achieved in a very limited constrained budget is unparalleled. And by we I mean the DRDO. Of course there are inefficiencies, but this is unparalleled. The ROI is huge. It can't be compared. 1/5 दाम पे 40 साल में 2100 करोड़ क्या होता है यार. 2 लाख करोड़ का तो हम लोग MSP दे रहे हैं एक साल में. So we should not be same again. I'm coming to the same point. 2100 crores in 30 years. CAG writes an entire report. I will request the CAG to compare how much money has been spent on the development of each of the jet engines in the US, in the in Europe, and in France, and in Germany, and how much is being spent by the Chinese. Now another issue is the testing infrastructure. So this is the FTB, the Russian FTB platform. So there was this audio that I think Alpha shared on his Twitter, that when some Netaji or some I don't know who exactly, but some Netaji only asked why do we need flying test bed, and the DG Aerospace then has to give a lamba chauda lecture ki bhai iski, which eventually summed up that there are geopolitical and strategic implications of these testing facilities and test beds, which is now openly visible now. This question was asked many years ago, and now we are seeing the मेरे पास शब्द है हिंदी में, मैं बोलना नहीं चाह रहा टू बी पोलाइट, बट देख रहे हो कि उसका क्या अंजाम हुआ है कि उस टाइम पे हमने फ्लाइंग टेस्ट बेड नहीं लिए या फिर उसके लिए कुछ हमने एफर्ट्स नहीं लगाए, और वी आर पेइंग द प्राइस, एंड दीज हर बार हमें टेस्टिंग करने के लिए रशिया जाना पड़ता है. एंड वी शुड आस्क सम सिंपल क्वेश्चन इज़ कि भाई रशिया हमको क्यों प्रायोरिटी देगा? द फ्रेंच, द रशियंस नो कि इफ़ द कावेरी इज़ एबल टू परफॉर्म, इज़ एबल टू कम टू लाइव एंड बिकम अ कमर्शियलाइज प्रोजेक्ट, देन उनका जो इंडिया में मार्केट है, जो कि उनके लेजर्स में बहुत ही इम्पोर्टेंट मार्केट है, तो भाई वो तो उसका बट्टा बैठ जाएगा, उसका तो कुछ नहीं होने वाला. द कावेरी विल, इफ़ द कावेरी इज सक्सीडेड, वी नीड टू अंडरस्टैंड कि अगर कावेरी इंजन सक्सेसफुल हो जाता है या फिर एक जेट इंजन सक्सेसफुल हो जाता है तो भाई ये उसके बाद एक एक्सपोनेंशियल डेवलपमेंट है. उसके बाद आप एक उस इंजन से आप एक उसको टोन डाउन करके कोई उसमें यूकैव में डाल दो, उसके किसी ट्रेनर में डाल दो, फिर उसके बाद पैसेंजर जेट बना लो. भाई दी अपॉर्चुनिटीज़ आर इमेंस once you have a functioning fighter jet engine. So I want to ask the people, वो जो एनालिस्ट सर लोग बैठते हैं एयरफोर्स में, कि why do they think कि बाहर टेस्टिंग अगर करने भेजेंगे, they will be very glad to help us. Of course they will take money, but we need to understand they will deliberately want to delay the process. तो वो एक इशू है. वी शुड बी हैविंग अ फ्लाइंग टेस्ट बेड. अब कैसे कर सकते हैं? आई थिंक वी शुड फोकस ऑन क्रिएटिंग, बाइंग अ bunch of passenger airliners with 4 engines and convert them into FTBs. I think that is the most sasta option that we can take. Other than that, I don't have any idea of how are we going to do this. And next is that question needs to be asked कि भाई 2011 में द हिंदू की रिपोर्ट ने बोला था कि थ्रस्ट ऑफ 70 to 75 किलो न्यूटन प्रोड्यूस कर लेता है कावेरी इंजन. 2022 में भी 70 किलो न्यूटन प्रोड्यूस कर ले रहा है. और आई थिंक अभी जो ब्रह्मोस एरोस्पेस ने 29 किलो न्यूटन का आफ्टर बर्नर सप्लाई किया है, उसके बाद इवेंचुअली जब फुल इंजन की टेस्टिंग होगी आफ्टर बर्नर के साथ, आई थिंक इट विल बी एबल टू प्रोड्यूस 80 किलो न्यूटन ईजिली. Because I am now much more hopeful about the Kaveri engine than anybody else, because I have some idea of the technological issues that the DRDO is facing and how they are coming up with this. And I must say DRDO is doing a brilliant job, and nobody will be able to comprehend of वो लोग क्या achieve कर रहे हैं in the amount of money that they have been given. It's a Herculean task. So coming to the existing testing facility, we have this GTRE 130 kilonewton jet engine facility that has come up in near to Bangalore. It's a 60-acre electrical power, 85 megawatt, cooling water is 65 lakh liters an hour. and these are some this is a major facility. I think some of the gaps, the major testing gaps that I will discuss in next slide have been addressed in this facility. And the thing is that जो सारी इश्यूज तो सॉल्व नहीं हो सकती है, जैसे हाई ऑल्टीट्यूड टेस्टिंग है, उसके बाद लाइव आपका फुल इंजन का जो टेस्टिंग है फ्लाइंग टेस्ट बेड पे, वो इशू नहीं हो सकती. बट आई होप इसमें जो भी कुछ सम सॉर्ट ऑफ एनवायरमेंटल टेस्टिंग फैसिलिटीज़ नई इस नई वाली फैसिलिटी में रिसर्च एंड डेवलपमेंट लैब में है. एग्जिस्टिंग कैपेबिलिटीज़ और दैट टेस्टिंग कैपेबिलिटीज़ दैट वी हैव काफ़ी सारा है. बट दी थिंग इज़ दैट ये जितने ज़्यादातर टेस्टिंग फैसिलिटीज़ है ना, तो ये कंपोनेंट लेवल टेस्टिंग है. आप अगर देखोगे मेजर जो गैप है वो यहाँ पे है, फुल स्केल मॉड्यूल टेस्ट फैसिलिटीज़, यानी कि पूरा का पूरा इंजन साथ में लगा के उसको एक बार में टेस्ट करने के लिए नहीं है, कंपोनेंट बाय कंपोनेंट टेस्ट कर सकते हैं. So that is one major issue. And then environmental test facilities. See, environmental testing facility is one area where there is a lot of scope for any businessman looking to invest and money, because environment test facilities आपको हर जगह लगते हैं, be it in case of jet engines, be it in case of tanks, APCs, radars, etc., guns. Environmental testing facilities are a must have for any military hardware platform development. Next is this, there have been some progress. This is one I got from Twitter. Somebody shared that DMRL designed and Medhani manufactured blades were used for refurbishing Jaguar's engine. So so if we speak about two major players in the market who are currently into manufacturing titanium or titanium products, finished products, not extracting on the ore part and refining, but finished products, that is Medhani, and I think even Bharat Forge does it to some extent. I'm not clear, but in any case, Medhani is one such major player. So this is one news that I got, that DRDO did develop single crystal engine blade that were for meant for helicopters, and I think they will be able to figure out something for the jet engines as well. I hope so. It's before 2030. All these development gives me some sort of hope, but it also has a baggage of concerns for me, and most of the concerns comes from the budgeting part. The budgets are too low. We are not serious about this. बातों में तो हम सीरियस है, बट एक्चुअल में जब फंड अलॉट करने की बात आती है, वी डोंट लुक सो सीरियस. नाउ नेक्स्ट पॉइंट इज़ द प्राइवेट सेक्टर जेट इंजन. मैंने कई सारे लोगों को बोलते सुना है कि वाई इज़ द प्राइवेट सेक्टर नॉट डेवलपिंग अ जेट इंजन. सो लुक, I shared a lot of this design process with you, how much trial and error and time and money goes into it. Do give it a thought that are the Indian companies willing to invest this much into developing a full grown fighter jet engine? I think not. We will have smaller scale turbine engines, but I think a full scale jet engine is from a private player. It won't happen anytime soon. बिकॉज आप सोच के देखो कि जो हमारे सबसे बड़े मार्केट जहाँ पे पैसा है, नॉर्मल गेम्स बनाने का भी मार्केट, वी डोंट हैव अ प्रॉपर इंडियन फर्म विच इज़ प्रोड्यूसिंग PC games on a global level. And there are many such things which have huge market in India, and still our companies don't develop things of their own and eventually end up buying from China and selling here, be it phones, be it TVs, etc. So Indian firms suffer from a lack of R&D. They think research and development are a waste of money, but the thing is that their peers in the Western and the Chinese region are where they are today because of their huge investment into research and development. इंजन, अब को बहुत लोग चिढ़ेंगे अरे डीआरडीओ से ये नहीं हुआ वो नहीं हुआ. देखिए, चाइनीज़ ऑल्सो डूक अ लॉट ऑफ टाइम. इनका जो रिसेंट जो इंजन्स आए हैं, दे हैव बीन वेरी परफॉर्मिंग वेरी पुअरली टिल 2016-17. उनका भी पेस अप 16-17 के बाद से ही हुआ है. तो ऐसा नहीं है कि वी आर वेरी लेट. Even the sixth generation fighter that they are putting up now, I don't think they have the engines are as efficient as required for a sixth generation engine. And next is that we need we are from the presentation, you might be aware that that the Kaveri engine needs to be diversified into other fields where gas turbine engines are usually deployed, be it in mostly in the power sector. We also can spin it off in the marine engines, and maybe other applications wherever engines are gas turbine engines are can be deployed. Next point is that what about JVs? सी JV हम विद रोल्स रॉयस, GE और साफरान में इस पर कोई कमेंट नहीं करने वाला, बट we should make sure if we are getting into a JV, we should have the complete intellectual property control of whatever transfer of technology you are asking for. And if it cost a hell of a money, maybe the total amount may be equivalent to the MRFA deal, or even to the entire cost of the LCA program. But make sure if you are taking transfer of technology of the core section, it should be full and final, no strings attached, nothing, no ifs and buts from the selling company. ऐसे लेना है. And I think if the complete transfer of technology happens, it should the government should publish what are the caveats, but should not disclose what is the amount. That is, if they are able to secure complete intellectual property. Next slide. See, this is my thought on the Kaveri's scalability. These are my thought. Kaveri's scalability is a huge competitor to global players. Somnath, this might be answer to your question. Kaveri's scalability is a huge competitor to global players. Why will anybody give you transfer of technology to create their own competitor? Even if it does, are there any strings attached regarding India's sovereignty or market access for Kaveri related products in future? That needs to be answered by whoever is concerned. अब कोई बोलेगा who am I? But I am no one, but people should know that when the strategic system deals regarding strategic systems happen, it should not come at a cost of our sovereignty. And if it is costing us our sovereignty, it is better to कि वो सारा पैसा हम कावेरी इंजन पे लगाए. हम लोग पता नहीं इंपोर्ट करने के टाइम पे तो बहुत ज़्यादा हमारे पास पैसे आ जाते हैं, बट व्हेन इट कम्स टू इन्वेस्टिंग इनटू आवर ओन R&D, हमारे हाथ बंद क्यों जाते हैं पता नहीं वो इतने सारे पैसे कहाँ गायब हो जाते हैं, गॉड नोस. सो इम्पोर्ट के टाइम पे वी आर, ऐसा लगता है कि भाई अनलिमिटेड मनी है, भाई तू बोल कौन सा सामान लेना है खरीद लेंगे. बट हमारे इंडिजिनस डेवलपमेंट पे पैसा देते टाइम वी आर लाइक नोबडीज. Now that is it from my for my presentation. I hope you guys liked it. I will be up for questions. You guys can shoot your questions. I will start from the comment section. Somnath, I think we can make a 110 kilonewton class engine, but first we should be focusing more on the 90, 80 or 80 odd kilonewton class of engine, because as I said that once you have the core sorted, it's a scalable product. It's once the hot section is sorted, the product can be the product growth is exponential, and hundreds of spin-offs that can take place. So yes, 101 and also 130 kilonewton testing facility has been set up by the DRDO, so it seems that they are confident कि वो लोग बना लेंगे. Yes. Yes, if only we should have every cover driver and see the light sorted. If only could have TV. Yeah, yes, Kari. I think the high altitude testing and the flying test bed are two most needed testing facilities. I think if we even if the flying test bed is prioritized later on, I think we should primarily start with the high altitude testing facilities first. We should get that first. Is there a problem with Kaveri core single crystal blades? See, that is, I don't have any information if the new engine that they are sending is with the Kaveri single crystal blade. I think there shouldn't be any problem. I hopefully because if you understand that in the last test in 2022, it was able to generate 48.5 to 50 kilonewton of thrust. So that means the blades were doing pretty well, and in that case we can assume or we can infer that if they have used the single crystal blades in the low pressure turbine section for testing during that time, it was working perfectly well. But again, this is an inference. CMCs, I am not so sure if they have gone for it till now, but a single crystal blade maybe. CMCs may also be there. I did see some pictures of CMCs that were shared in some of the Aero Indias and Defense Expo by DRDO and GTRE. On J20, can India MCA counter the, I think USA will future threat to. I will make Somnath, I will make a different presentation for J20 and J36 and regarding AMCA. Again, this takes a lot of producing this deck or presentation make a lot of effort. I think, but AMCA isn't going to be a 5th generation fighter. It's going to be a 5.5 generation fighter, because the core or the fundamental part of a 6th generation fighter is not just the shape and the platform, it's also the avionics. So if the avionics part, I think if we are able to integrate well into the AMCA, it can be given a capable 5.5 generation capability. Other than that, the thanks, bhai. Ujjwal ji, welcome. Please subscribe, share thing about my channel. Okay, I think yes. So J20, J36 are a threat, but even if we are able to go well with the with our existing Su-30 MKI upgrade programs, LCA Mark II, I think it's up for first flight this year, and we are able to produce the AMCA Mark I by 2032 or 35. Then we don't need to have to worry that J36 or J20 are there. But we first need a decent amount of fighter in the indigenous fighter in the 4 to 4.5 and 5 5th generation category. Again, again my thinking is that as we go ahead in time, the technologies that will come up in this platform, it will be better. It will be far better in terms of preserving sovereignty. That if these technologies are generated. If these technologies are generated in-house, majorly generated in-house with some foreign help, but I think the intellectual property must reside with India, that is Bharat. Somnath, welcome. Somnath, any more questions, guys?
Okay, I think that's at least Kaveri dry. Yes, Kari, I think this is a great thing that the UCAV will get a dry Kaveri engine, and I think it's a good size UAV, and if we are able to get a decent size UAV with some air to air capability. Uh, what needs to be done to reduce weight in our engines? It's purely material science, sir. It's purely material science. We need to put more money in our metallurgy. हमारे जितने अच्छे metallurgy के लोग होते हैं वो mostly बाहर चले जाते हैं. People don't have any idea the amount of material science engineer that leaves this country for pursuing their higher studies in Germany and US. Uh, don't you think US is a threat to India? I don't think threat as per se. I won't pass a sweeping statement, but yes, there are two parts in USA. That is, one is very pro India, one is very not so pro India, because the not so pro India part thinks India as a binary, or not in a binary, but they see world as a binary. That is, if somebody is friend with Russia, then that particular country is against America. They think too much in binary. That is causing the general geopolitical issues that are coming forward within the relationship of USA and America. I will also create some geopolitical decks next week. Next week will be focused on geopolitics, and we will explore more about the geopolitical scenario overall. स्विफ्ट एंड घातक शुड बी प्रोड्यूस. अब उज्जवल जी ऐसा थोड़ा सा ना, ये क्या कहते हैं, 400-500 का नंबर तो यार थोड़ा सा ज़्यादा ही ओवर ऑप्टिमिस्टिक है. इवन a good amount will be 100-150 decent UCAVs will be at least it will be a decent number. Yeah. Any more questions, guys? I think so. As I said, I can't say with complete authority that if it's in there or not. But considering that in the prior test, the engine was able to over deliver on the benchmark. That alone proves that that the engine was able to sustain increased temperatures in the low pressure turbine part, and that gives me a hint that the new single crystal blades might have been there, because DRDO already has delivered single crystal turbine blade for helicopter, to be used in helicopters, to be used in helicopters to HAL. This is the single crystal blade that DRDO has developed. So I think that they have incorporated single crystal blade, but I can't say with perfect or complete surety. Any more question, guys? I see. Swift and Ghatak should be insured in a G4. Should India not have G? अरे सोमनाथ जी, G414 का तो बैकअप होना चाहिए, तभी तो we have 130 kilonewton test facility coming up. So this particular I will show you that here. I will come to that slide. So this particular engine that the gentleman here was discussing was of a potential AMCA jet engine of the 110 category class. So yes, we are looking for an alternative to G414. Might not be that government has not funded any such product yet, but I think DRDO is focusing on research of this based on its internal funds. But again, any and all engine programs regarding fighter jet engines must be now taken into motion mode,
and these laboratories that are handling these projects must be bring into the ambit of the Prime Minister's office for rapid results, as the Bhabha Atomic Research and the ISRO like organizations are under the purview of Prime Minister's office. Anything on our AMs, any video or live? I will do it. I thank you for the idea. I will make a separate live for it. I will definitely make, but as of now I will keep you updated on my Twitter, so please follow me on Twitter. At least 6 to 8 billion must be. Yes, Subramaniam ji, I think 6 to 8 billion dollars is enough. Even it's why we are funding your MSP of 2 lakh billion, 2 lakh crore is approximately 8,000 12 into 8, $24 billion in MSP. So 6 to 8 billion dollar is one time investment is enough for next 10 years for engine development. It will bear tremendous results. I am 100% sure about it. It will bear tremendous results. Fund the jet engine 6 to 8 billion dollar. Ujjwal ji, thank you. 6 to 8 billion dollar is more than enough for a decade of research and development part, and we will see results pretty fast if that kind of funding is given. But again, I am sure the babus won't let it happen. But they will have $12 billion to buy an imported something. So that's there is also a mindset issue, a huge mindset issue. Any more question, guys? Anything I can address or help you with? I think potential. Somnath ji, to your last question, some of the previous question I missed. Yes, Manohar Parrikar was indeed the best defense minister for indigenous programs. Period. He was the best indeed. Regarding the FCS and the GCAP Tempest 6th generation fighter jet, I am again of the I have two points to make. First is that how much intellectual property we are owning. Second is the how much of the manufacturing or the supply chain we have a part in. So ये नहीं होना चाहिए 10 देश मिलके बना रहे हैं, and when we get into a war, अब फलाने देश से फलाना पार्ट नहीं आया, या फिर फलाने सॉफ्टवेयर को अपडेट करने के लिए हमारे पास सोर्स कोड नहीं है, वी हैव टू रन टू दी ब्रिटिश और टू सम अदर यूरोपियन कंट्री. वो नहीं होना चाहिए. The LCA Mark 2, Mark 1A, the AMCA will give you complete control over the source code. You don't need anybody's permission to implement new weapons. So if you think about the LCA program, I think the LCA program or the LCA jet is the only fighter jet possibly in the world which can incorporate Indian weapons, American weapons, Russian weapons, Israeli weapons, French weapons, and the UK weapons. So yes, I think the LCA is a unique platform on its own. Yes, 6th generation fighter will require a much more bigger power plant. That's why I said the AMCA won't be entirely 6th generation fighter jet, but if the avionics part can be addressed, and it can become a 5.5 plus generation fighter jet. And as I said, if the engine is sorted, if the Kaveri is sorted and the hot section we are able to figure out now, it's a very scalable product. It won't take much time to make spin-offs for passenger jets, for gas marine engines. It's a huge the Kaveri engine. It's a huge project of strategic interest, and that is why there are many interests that don't want the Kaveri to succeed. दैट इज़ ऑल्सो वन थिंग. सो आपको नेसेयर्स बहुत मिलेंगे कि ये वो फलाना ढिमकाना. यू मस्ट अंडरस्टैंड देयर आर मेनी vested interests that are against the Kaveri, and they will keep on bad mouthing the Kaveri. But we must ask one question: do compare how much amount has been invested into the development of Kaveri in last 10 years, and how much has the Chinese spent on developing their engines in the last 10 years, and what has been the output. Fundamentally, the ROI for Kaveri is huge. Nobody understands that point. So yes, guys, that I think that will be it for today's live. I really appreciate that you guys joined in. फिर मिलेंगे हम नेक्स्ट वीक. आपको मेरा वीडियो पसंद आया तो ज़रूर इसको लाइक करें, शेयर करें, चैनल को सब्सक्राइब करें. सबसे इम्पोर्टेंट है, टेक्स अ लॉट ऑफ एफर्ट to make this deck for you guys, and you might have noticed that this is possibly one of the very few are there any titanium in engine increasing the weight at the current as an engine is increasing the weight wanted to understand this section is causing the most trouble. Subramaniam ji, I think the afterburner part is the most troubling issue right now. I think the titanium part is not the problem that is causing the issue, but there may be, as I said in the problem part. I will share it again. So you see this. The hot section part is the most troubling part, and out of that the afterburner part is the most troubling part. So the afterburner is also called the reheat system, and the temperature here goes even beyond to the what is in the low pressure turbine part. So there comes the issue that once the afterburner is implemented, to augment the lack of metallurgical skills, we have to increase the weight by adding more amount of material to avoid any kind of failure in the afterburner. That is primarily causing the increase in weight. Also, the weight currently is also a matter of simply metallurgy, since titanium is not the fundamental issue. The alloys are. So the alloys are basically titanium plus some other metal plus some other metal, multiple metals, creating an ideal mix of weight and strength. That is a very trial and error kind of a job, and takes a lot of research and development. So you have to be particularly very much on the perfect composition of alloy that will give you a reduced weight and the strength that you require. Does the Kaveri derivative also weigh? I don't think so. It will be lighter. I think the new variants that are going into Russia may be a bit lighter. But again, I say that there is 30 to 35 30 to 35 kg, 1180 kgs, and the WS13 is around 1135. So that's only difference of 45 kilos vis-a-vis the Chinese engine, and vis-a-vis the GE404 100 kilos, and GE414 it is around 70 odd kilos. So we are close, and the thing is with this kind of development is that as we get closer to our benchmark, it becomes even more difficult to achieve. That's a general life principle as well. Yes, Subramaniam ji, we have to get the correct composition of the alloy. That is the issue. Titanium is not directly used. The alloys are important part. So that is and the research on alloys has to be done, and the compositions had to be figured out. That is where AI can be used actually. that is one place where AIs can be used to come out with a set of composition that satisfies our boundary conditions. Yes, so AI पे भी एक वीडियो बनाना पड़ेगा, I think. Yes, even I am waiting, Ujjwal ji, for the Aero India. A lot of information will come from there as well. I hope you guys liked it. That will be it from my end. 2 more minutes. Any more questions, and then I will be done for this live. Yes, Mahesh ji, I will humbly request you to see my yesterday's live. I did a comparison on with the Archer and Archer TB2 and the Shaffer drone and the CH-3H Chinese drone. I will request Mahesh ji, you go and have a look on my channel. On the live section part, you will see yesterday's video. Again, Mahesh ji, I will request you to subscribe if you have not subscribed. Guys, any more questions? Okay. Okay guys, I think that will be it from my end. I hope you guys liked it. आपको वीडियो अच्छा लगा होगा. वीडियो अच्छा लगे तो ज़रूर चैनल को सब्सक्राइब करें, वीडियो को लाइक करें, चैनल के बारे में शेयर करें अपने दोस्तों के साथ. It takes a lot of effort to create these live presentations for you. Mahesh ji, thank you. Please go through my channel. There you will find a lot of unique videos. I make a lot of things. Needless to say, very detailed analysis in everything. Yes, Subramaniam ji, welcome. You're welcome. Yes, I think I humbly appreciate you guys for taking out your time for today's presentation and giving a chance to a new channel like me. I hope I have been able to deliver good value to your time. So that will be it from my end, guys. Thank you very much, and I will be out in 5, 4, 3, 2, 1. Thank you guys. Thanks a lot. Bye bye. Jai Hind.